Okay, so I've duplicated my project. Let's update our top comment a little bit. So let's call this adding user interface. And this is the 25th. And we'll leave the background music comments here because we're still using those files. And we're going to start by adding in our images and then build out our user interface. So I may update other parts of this code later, but for now I think this looks fine. I'm just going to collapse everything so it's easier to see the full program. Yeah, maybe I'll get rid of this comment because it takes up some space. Okay. So let's upload our images that we're going to use first. So I'm going to open up the file browser, and I'm going to make a separate folder for this that is just for my UI images. So I'm going to start by adding a new folder. This isn't really necessary, obviously, for the functionality, but I like to keep things organized. So I'm going to create this UI folder, which will hold the user interface elements. So I'm going to upload first my buttons. So I'll go to my art folder and find the buttons. And let's see. I'm just going to use the start and instructions button. So I'll grab those two. And both of these files are very small, so that's good. They're 64 pixels by 32 pixels, and that'll be something that we want to use when we set up our button code, the size of the buttons. Looks like one of them didn't work, so let's try it again. Okay, let's try that again. There we go. Okay, so we've got our buttons, and now let's upload our backdrops. So we're just going to grab all of these. I have the title screen, instructions, and the background for the game. Background for the game isn't really part of the UI, so maybe that should go in sprites. So maybe I'll just upload these guys, and then I'll upload the background to sprites. Okay, so now we need to load these images in our preload function. So I'm going to keep this file browser open so that I can see everything. And I'm just going to go back to sketch.js. And I'm going to create some more files or variables to load my files. So I'm going to say let's do start button image. Instructions. It's kind of long. It's a pretty long variable name, but that's okay. We only need to draw it once. So we need an instructions button image. I need a title screen and instructions screen. And then I need my game background. Okay. So then in the preload function, I need to load all these guys. So I just need to make sure I use the right path. And all of my other images are loaded from the sprites folder. But I have a new folder, which is the UI folder. So I have to make sure to load those correctly. I can start with the game background, actually, since that's, well, it doesn't really matter what order I put them in, but let's go ahead and do that one. So I have the game background is in sprites/bg_2.png. So I just have to make sure I'm loading the right image there. And then for my UI, it's all four of these guys. So I have this start button image. I'm just going to write these out to start. Instructions button image. Title screen. And instructions screen. You could have your instructions on the title screen if you want to save a little time, but I want to go over how to add multiple scenes. So our start button image is just button 0. So it's in UI/button_0.png. Our instructions button image is same folder, UI, and this one is button_1.png. Our title screen is load image UI slash, I think it's bg0.png. And then our instruction screen is load image slash UI slash bg_1.png. So those names are probably like that because I exported a sprite sheet from Piskel. So it's a little hard to know which one is which, but you know, it's fine for now. But usually it's good to name your images a little bit more descriptive than what I've done there. Anyway, we've got our images loaded, so let's start building out our scene and our UI. And so we're gonna have to actually add a bunch of stuff to the beginning of our program. So now that we have more than one scene, it's not just the game, what we need to do is use a variable to manage what scene we're in. In Scratch, we did something similar to this. So in the, we use different, basically, broadcasts for the different parts of the game. So we have the start game, instructions, end game. And if you remember in Scratch, we had to like individually show or hide each sprite in the game in order to get this to work. And that's very tedious. It doesn't really make sense from a programming point of view. But when we're using Scratch, we don't really have the ability to change how the code works. We can only work with what is given to us by the Scratch developers. So when we're writing our own code, we can make this a lot simpler. So just like we have like different animation states for our player and our bird slash enemy slash reward character, we can set states for the game overall. And so that's what we will use to set up our UI. So we're going to set up game states. So we're going to have the game state, and we'll start it off as 0. And just like we have with our animation states, we're going to have 0 is start menu. 1 will be the instructions menu, and 2 will be the game. And so that's very basic because we just have a few parts. It doesn't really matter what order we put them in. If you have a game with multiple levels, then you could have, you know, multiple states for the game. This is just a value that we use to decide which part of the game to draw. So to implement that, we're going to change how our draw function works. So right now in our draw function, it's just drawing the player and the birds, and it's doing the collision detection between the player and the bird. This is really just our game level. So what we can do, the easiest way to do this is I'm just going to cut off my draw function here, and I'm going to start a new function called game, and that'll start right here. So essentially, I'm taking the draw function, or I'm really just turning most of the draw function into the game function. And now the draw function, for right now, it doesn't do anything, but we're going to use it rather than to actually draw the game and draw the logic of the game. We're going to use it to decide which state or which level or scene that we want to draw. So right now, if I run the game as is, there's nothing there because we haven't set up the rest of the scene. But we're going to go through that logic now. Okay, so let's collapse the game. So now we have functions that kind of like create the objects, but now we're also going to have functions for each one of the scenes in the game. So we're just going to use an if statement to figure out which game state we're currently in. So I'm going to say if the game state equals 0. And remember, we use double equal signs for comparison. So if the value held in the game state is equal to 0, then what we want to see is our start menu. So we could just write the start menu logic out here, but now that we've started to organize the game a little bit differently, what we're going to do is we're just going to create a start menu scene or a start menu function that will draw the start menu. So I'm just going to throw that in here. So then else if our game state equals 1, we're going to draw the instructions menu. And then else if our game state equals 2, we're going to draw the game. Okay, so now our draw function is not handling any actual drawing. It's just kind of deciding which scene to draw based on the current game state. So now we have to make these extra functions, the start menu and the instructions menu, to draw those scenes. All right, we're on our way. Any questions so far? Okay. So let's start with our start menu. So I'm going to make a new function, start menu. And in the start menu, we just want to draw our background. So I'm going to draw an image, and the name of the background, or the title screen rather, is title screen. So I'm just going to throw that in there. And I'm going to draw it at 0, 0. There is going to be a little issue with this, but let's just see if this works, and then we'll fix it from there. Okay, so we see our background, but it's kind of off to the side. And that is because, remember, in our setup, we set the image mode to center. And we did that to make it easier to detect the collisions between our sprites. But it affects the entire game. So there's two things I can do here. One is I can change the image mode back to the typical, which is that it draws from the left. So if I said image mode corner, now it'll draw correctly. But when we run the rest of our game, it's not going to work the way I want it to. So instead of doing this, I'm just going to calculate where to actually draw the canvas. And that's not too hard to do. We can use the width. So once we set up the game, we set the width and the height of the canvas. And so we can use that value. P5 is going to save these numbers as width and height. So we can just center our image by drawing it in the center of the canvas. So we can say width divided by 2 will give us half the width, and height divided by 2 will give us half the height. The image doesn't match our canvas because the image was created for P5, which has a different size, but we can use that instead. So let's actually just reset up our canvas. So our canvas in Scratch rather is 480 by 360. We can just match that in P5. You don't have to do it that way. If you want your art to be a different size, you can change the size of the art. If you don't care that it's cut off, that's fine too. But I'm just going to change the canvas to match the graphics that I already created. If you wanted to, you could make it bigger, you can make it smaller, you can make it fit the design that you want for your game. Okay, so we've drawn our title screen, and so now we have to draw our button. But our button has to have some functionality, and we have 2 of them. So these are 2 important parts to consider when you're designing a program. If you have 2 things that have the same type of functionality, it's going to be a lot easier to create a function, like our bird function, so that we can repeat the functionality rather than redoing it all together. So what we need to do is consider what a button is, what makes it similar, and what makes it different. So let's plot out our button. So a button, it has a X and Y position, where to draw on the screen. It has an image, which button image we want to draw, and then it has to be able to be clicked. So these are the main things that a button needs to be able to do. So the X and Y should be able to change based on the position of the button. The image should be able to change based on what we want the button to show. And then whether or not it's clicked is basically going to be the same if we click in the button or not. So let's make our button function. So we're making a new sort of blueprint for what a button is. And remember, when we make functions that are objects or blueprints, we use a capital letter. So I'm just going to use a capital B. And then we need to give the button some parameters. So we didn't do this with the player and the bird. We just kind of, with the player, we just set it inside the player because there's only one player. With the bird, we randomized the X and Y position. But with our button, we're actually going to say where we want it to go from the beginning, and it's going to stay in one place. So instead of putting let X, let Y inside the button, we're going to put X and Y as arguments in the button when we create the button. So when we create our birds, we don't have to do this because the position is randomized. When we create our button, we're going to say exactly where we want it to be. So we're going to give it an X and Y position. And then we're also going to give it an image. I'm going to use IMG shorthand because the function image already exists in P5, as we can see right here. So if I try to use that again, it's going to create some issues. So I'm going to use X, Y, and then image. So we don't have to say let X equals anymore. This is the equivalent of that. So this is an argument. So I'll just put a note here, X, Y, image arguments are like let X equals 0. We don't have to put the let X. It's going to be whatever number we put in when we create the button. So in our setup, just like we did with our birds, we'll say something like start button equals button, and we'll put the X and Y there. So the X might be like 100, maybe the Y is 300. I'm going to try to put it right here. So that 100 becomes this button X, and this 300 becomes this button Y. So it's like declaring the variables, but we're doing it outside of the function. Okay. So we've got X, Y, and we need the image as well. So the image for this is start button image. Okay, so that's looking pretty good. And we can copy this whole thing for our instructions button. So we'll say instructions button, and we'll put it in a slightly different position. So maybe I'll move it over to 200 on X, and we're going to use the instructions button image. These are kind of long variable names, so it looks a little goofy, but that's what it'll look like in one line. Okay, so now our button has to be able to draw, and it has to be able to, or display, and it has to be able to be clicked. So display is easy. We can just make our function display, just like we do with our player and our bird. And we are going to eventually return this display function so that we can call it from our UI scene. And we're just going to draw that image. So we're going to draw image IMG. So this image comes from here, and it's whatever we throw into our button function up here. And then we're just going to draw it at X and Y. So now I should be able to actually draw this button. So in my start menu, after I draw the image, I'm going to say start button dot display. And there we go. We get our nice little start button. It doesn't click yet. If I click on it, nothing happens. So that's the last part that we have to do. But we've got our start button. And let's see if we can display our instructions button. That one I'm not seeing. Let's see if there's an error. I probably just spelled it wrong. Okay, I spelled something wrong. Instructions button image. Okay. There we go. There's our instructions button. All right, pretty easy. So that looks pretty good so far. So again, this one block of code is drawing two different buttons. So if you have multiple elements in a program that have basically the same functionality, we want to create a blueprint, a function that will capture that functionality, but it allows us to have different parameters using our arguments. So we have a different position for X and Y, and we have a different image to display with the button. But both of these buttons need to be clicked, so let's create a clicked function, and then that'll be the last functionality we need. So we're going to create a function clicked, and we're going to export that function, or we're going to return that function to our main program. And so what we'll do is we'll say if start button dot clicked. For now, let's just console.log start clicked, and we'll decide what to do with that in a little bit. So right now this isn't gonna work, obviously. If I try to click the start button, nothing happens. So what we need to do is go into our clicked function, and we need to determine what are the properties or what are the things that mean that our button has been clicked. So the first thing is that our mouse has to be clicked, and then we have to be inside the button. So those are the two things that have to be true for our button to have been clicked. Okay. So knowing if the mouse is clicked is easy. We can just say if mouse is pressed. Notice that turns pink. So P5 knows what that means, essentially. Mouse is pressed just means that the mouse is pressed, but it doesn't tell us which mouse button is pressed. But actually, we don't need to know that. It doesn't tell us where we have clicked. So the next thing we have to decide is if we are inside the button. And this is a little tricky to figure out. So there's a long piece of code that we have to do this. It's very, very common. If you Google this, it's like the first thing that'll come up. If you say rectangle collision detection, it'll show you, pretty quickly. Actually, this is way more complicated than what we need. Rectangle button detection. Maybe that'll be better. Okay, maybe it's not as easy to Google as I thought it was. But it is a very, very common thing that happens.
Can you just use the position of the button says
Well, that's what we're going to do. Yeah. So actually, let's talk about it. So we have my button here, and let me get my little drawing pad, and let's figure out. So logically, what we need to know about our mouse versus our button in order for us to know if we're clicking on it. So we've got a square here. I'm gonna make it look a little bit bigger. So we know the mouse position. So we want to figure out if the mouse is inside of the button. And we know two things about the mouse. We know the mouse X, so that's the X position, how far it is from here. And we know the mouse Y, that's how far it is from here. So if, let's imagine this might be like 100, this might be like 10, something like that. It's just a number that represents how far the mouse is inside of the canvas. Okay, so we know that. And we know some stuff about the button. We know that the button has an XY position that's in the middle. So the button has an XY here. We know the button has a width, which is 64 pixels. I know that because that's how big the image is. If your image is a different size, then you need to look at the image and see what size it is. We also know the button has a height, which is 32 pixels. Okay, so let's close this for a second. So let's just draw this in the abstract. Okay, so we've got our rectangle, and we've got our mouse. And this is the mouse outside, this is the mouse inside. So there are four things that have to be true for us to know that our mouse is inside this rectangle. What are those four things? Remember, with our circle, we only needed to know one thing. We had the inside of the circle, and we have our mouse, and we needed to know how far the mouse was from the inside of the circle. That's all we needed to know if our mouse was in the circle. So we just compare the radius of the circle, which is how far this is, to the distance of this line. The way we determine if the mouse is inside a rectangle is totally different. We don't have a radius because it's not a circle. We don't calculate the distance between the line. And the reason for that is, it may be obvious, but imagine if we use the same logic here. So imagine we had a circle like this, and this was our radius. You can see where the issue would be. My mouse might be here, so it's inside my rectangle, but it's farther than the radius of the circle, right? So we can't use the radius or just the distance between the mouse and the center of the rectangle to determine if the mouse is inside the rectangle. So let's think about it again. What needs to be true for the mouse to be inside the rectangle? Any ideas? The height of the button minus the size of the window? What would that tell us? So let's imagine that this is our window. So if we take the height of the button, this dimension, minus this dimension, okay, so this distance. Okay, so if the mouse is higher than this distance, then it would be inside the button. So that's true, but is there an easier way to think about that? The height and the width of what? You mean the mouse? So the mouse is just a point. It doesn't have a width and height. It just has x, y. The box has an x, y, and it has a width and it has a height. So this is right. This is correct. But there's an easier way to just express this.
So like if you like use the position of the button and use that as reference, we're only referencing the center of the button, or we'll take the whole thing.
We need both.
Like if you use the x and y position of the button,
Yeah.
like would that only be in the center of the button?
The way our program is set up, it is, but sometimes the button is drawn from the top left. It depends on the program. But for what we're working with, the XY is in the center of the button. Okay, so let's go with what Wesley has said, and let's think about it from the other direction. So what Wesley said is that if the mouse position is in this area, somewhere between the bottom of the button and the bottom of the canvas, then it's not in the button. So if that's the case, what's the opposite of that? What would also be true?
And less than the height of the button. So
Right. If the mouse is less than the height of the button, or the Y, so the Y is the position. So this is Y for the button right here.
So we also have to be less than that height.
So if the mouse is less than this height, then it's not in the button, right? If the mouse is up here, then it's less than this value. It's not inside the button. So the mouse has to be greater than this line and less than this line. If the mouse is greater than, it's down here. If it's less than, it's up here. So that gives us the Y position. What about on the X?
And we'll also have to take the other button into consideration.
No, just one button. So if this is true on the Y, so our mouse has to be greater than this Y or less than, this is our Y plus height. So we know it's in here. What would be the equivalent of that on X? Nothing? So it's literally just the same thing. So if the mouse is over here, if x is less than this line, then the mouse isn't inside the button. If the x is greater than this line, then we are inside. And then same thing over here. So what we have to do, if we clean this up a little bit, we have our button. We know the position of the mouse is mouse X, mouse Y. We know the position of the button is X, Y. We know the width of the button and the height of the button. So there's 4 things we have to know. One is the X position of the mouse is greater than this line. So this line, the tricky part here is that since our XY is in the middle, this line is equivalent to the X minus half the width. So minus width over 2. So our mouse has to be inside here, but it can't be over here. So this line is X plus the same thing, width over 2. So we just have to center our X position. Okay, so that's our first 2 parameters, 1 and 2. Then the same thing on the y-axis. So this line is equivalent to y minus height over 2. So we start at y and we subtract half the height. This line down here is the opposite, y plus height over 2. Okay, so that gives us 3 and 4. So that's the basic logic. Writing it out is a little complicated, or it's going to look a little crazy, but we only have to do it once. Okay, so let's write it out. So we have if mouse X, so that's where our mouse is greater than X is the X that we get from here, the position of the button. And then we have to go back to account for the width of the image. So we say minus, and we don't actually have a width or height, so let's put those in here actually. We're gonna have let W equal 64 is the size of my image, and H equals 32. So width and height of image. So make sure those match the image if it's not the same as mine. Okay, so X minus width over 2. And if we have a bunch of parameters that we put together, we separate them by an ampersand. And in JavaScript, we can go to another line when we do this, so it's going to look a little bit easier to read. So this is our first parameter. So mouse X is inside the left side of the button. Then mouse X is less than X plus width over 2. So that means the X is inside the right side of the mouse. So then we just do the exact same thing on Y. Mouse of Y, or mouse Y is greater than Y minus height over 2. And mouse Y is less than Y minus, or Y plus height over 2. And because it's a rectangle, it has 2 sides, you can see there's this sort of symmetry. We have greater than, mouse X, mouse Y, X minus width, X plus width, Y minus height, Y plus height. So our circle is just one round thing where the distance from the center is always the same. Our rectangle is not that way. The distance from each part of the rectangle is dependent on the width and the height. Okay, so then we put a little curly bracket after this. It looks a little goofy because we have so many parameters here, but that's our basic rectangle collision detection. So I'll put a note here. Okay, so if this has all happened, then we have clicked. So we want to return true from our function. If this doesn't happen, what we'll do at the bottom is we'll just return false. So if we hit return true, that'll return back to our clicked, and so it'll know it's true. If we never hit this return true, then we'll end up at return false. Remember, return ends that function, so anything that happens after this return just gets ignored. So we can just throw a return false at the very bottom. So if it never gets to that return true, then we know that it's false. Okay, there's one problem with this that makes it a little bit more complex, but let's just try this and see if it works first. So right now, if we click a button, we should see clicked down here. Okay, so we get start clicked. Let's do the same thing for our instructions button. So I'll just copy this and paste instructions button. Instructions clicked. So let's look at our console. So if I click start, we see start clicked. If I click instructions, we see instructions clicked. If I click somewhere else, nothing happens. So that's what we want. The one problem is, notice this thing right here. 4 start clicked, 5 instructions clicked. So remember that our draw function is running all the time. So when we're clicking, even if we do it really fast, there's multiple frames during which it's true that we're clicking on the button. So we only want the click to happen once, so we have to prevent it from happening multiple times. This is a pretty typical thing where we have to toggle something. We did something similar in Scratch when we used, where did we? Same thing with the sound effect last week, exactly. I thought we did something like that in Scratch, but maybe not. I can't remember. Anyway. Okay, so how do we stop that from happening? Well, we have to know that the button's been clicked and then prevent further clicks. So what we can do is add a variable here to track whether the button is clicked. So we'll call this our button toggle. And we'll just say let is clicked, and it starts off as false. So if we haven't clicked it, then it's not clicked. So when we click it, besides returning true, we can say is clicked equals true. Okay, so that will let us know that we've clicked it, but it's not going to prevent us from clicking in the future. So what we need to do is prevent clicking if is clicked is true. So we need to add another parameter inside here. So we have to make another block. This is where this if statement starts to look really gross because we've got all these different nested if statements. There's probably better ways to write this, but what we're just going to do is say if not is clicked, then we will do our click. So let's put this in here. So there's actually 3 conditions. So mouse is clicked, we're inside the button, and we didn't click on previous frame. Okay, so now when we click, we set is clicked to true, and then we tell our program that we've clicked. So now we'll fix one issue. So if I click on the start button, we get start clicked. But now I can't click anymore. So we need to know when do we set is clicked back to false. So if we click the mouse and then release the mouse, then we should be able to click again. We could make it more complicated, like if you click the mouse and then move and then release the mouse, but we're not going to get too crazy. We're just going to say if the mouse is not pressed, so here we have if mouse is pressed, and that ends here. Or no, it ends here. Okay, so if the mouse is not pressed, then if we can say else if is clicked. Okay, so if the mouse is not currently pressed and we did just click, then we've released the mouse, so we can say is clicked equals true. So I'll put a note here. After clicking and releasing, we can click again. Oh, but this should be false actually. Is clicked is false. Okay, so it's a little bit complicated, but since we did a button function, we only have to write it out once. So now we can start.
Can you use the mouse release function?
You could. The problem with that, you'd have to have a more complicated structure. So you could have a mouse release function, but it doesn't know which button has been clicked. So if you have mouse released, you have to go through all the buttons and say that they're not clicked. But you could, that's another way that you could do it. You could have all of your events handled in a separate function. Okay, so our buttons work, but they don't do anything. So we have one more thing to do. If we click start, we need to change the state to our game. Okay, so if start button clicked, let's say game state equals 2. Remember our game state up here. Let's look at our notes. Our game state for the game is 2. So if we click the start button, now we can play the game. And everything works as normal. Okay. If our instructions button is clicked, then we want to change game state to 1. Game state 1 doesn't exist, but we can create it. So if I click instructions, I'm going to get an error. But our game state 1 is very similar to start menu, so I'm just going to copy that and paste it and just change the title screen. That might say, when you hear that, you might think, well, shouldn't we make a menu object instead of a second menu function? That might be true. It kind of depends. Sometimes if you have 2 of something or 3 of something, you may want to make a blueprint object. In this case, I'm not going to, just because I think there's other things that might change between these 2 screens. So for now, I'm just going to hard code this. My instructions menu will just have the instructions screen, but everything else will stay the same. So if I go to instructions, must have spelled something wrong. Yeah, I forgot the S in instructions. Okay, there we've got our instructions, and there we've got our game. So yeah, the instructions menu actually, one thing that obviously, if I click the instructions button, it doesn't do anything because it is the instructions menu. So let's just take out the instructions button. I suppose you could have like a return to main, but let's just start our game. All right, so that's a lot of code, but it sets up our whole UI. What we'll do in the next second part of class is add the score, and that'll be all of the UI stuff that we're probably gonna need. So I'll stop here and I'll upload this stuff. And you guys, we can do a little workshop time if you guys want to work on creating some images or updating your code, or if you have questions, we can go over it.